Hey everybody, we are starting chapter 2. We're talking about polynomial and rational functions. Remember, rational, the root word is ratio. So that just means when we have something that looks like a fraction in a function. So here's some important vocabulary. Remember that these three functions are all called polynomial functions, types of polynomial functions. And let's jump in. So we know a constant function, remember, that's a function that never changes. It is constant, and it has a degree of 0. And if you remember, the degree just means the highest exponent in that function. So for example, f of x equals a, where a is some value, is a constant function. And this is a 0 degree because this could also be called like f of x equals a times x to the 0. Because remember, anything to the 0 power is just 1, and a times 1 is just a. So that's why we call the constant has a degree of 0. Let's talk about the linear function. We've been talking about that a lot. Remember that it has a degree, think about it, of 1. And that's because we say f of x equals mx plus b. We should feel super familiar with this, but we know that m cannot equal 0. And remember that on this little exponent on the variable, there's that invisible 1, which is why it's called a degree of 1. All right, let's talk about our quadratic function. Now remember from last year, a quadratic function has a degree of 2, and that's because it looks like f of x equals ax squared plus bx plus c, where the highest exponent here is an exponent of 2. And we also say that a cannot equal 0, because if a was 0, then x, the variable on it, would not be 2. Let's talk about the axis of symmetry, which an axis of symmetry only works with the quadratic function. An axis of symmetry is the line where a parabola, which is the graph of a quadratic function, is symmetric. So for example, if you've got the graph of a quadratic function like this, the line right through here is where it's symmetrical. We call this the axis of symmetry. And the vertex, if you remember, the vertex is what we would kind of call the center of the parabola. And it's where the axis of symmetry intersects the parabola, which is this point right here. So one thing we know about the vertex is it always is on the axis of symmetry and where it hits the parabola. So the line is the axis of symmetry and the vertex is the point. We see that they both have the same x value. All right, let's talk about how to graph a quadratic function. So remember that n is a non-negative, aka positive integer, and we know that these values are coefficients, okay, are real numbers, meaning they exist. And we know any polynomial function, so many monomials with a degree of n could look anything like this, where f of x is some coefficient, a sub n just means some coefficient of x to the nth term. Now, we don't know what n is. It could be 1, it could be 10, it could be 100. And we know the polynomial is going to go in decreasing order, where whatever this value is up here on that exponent, it's only going to decrease as we go on. And then we know, okay, we've got some coefficient on the quadratic term, we've got another coefficient on the linear term, and lastly, a coefficient on the degree of 0 term. We call that the constant term. So we know a quadratic function is the polynomial, remember, with a degree of a second degree, aka just the number 2, right? And the graph is the U-shaped curve called the parabola. Remember, it looks like this. Right? If a is positive, it's a happy face, it goes upward. But if a is negative, it'll be a sad face. We'll talk more about that. The leading coefficient, remember the leading coefficient, we call that the value of A of the quadratic. If it's positive, the graph opens upward. So let's put that here. So if A is positive, it's like its attitude is positive, it's going to be smiling. And if the parabola and the vertex of the parabola is the minimum. And the reason is because if this is the vertex and it's going upward, the vertex is at the lowest point. So we know that the vertex is also called a minimum. So what if the leading coefficient so remember the leading coefficient is still A and it's negative, right? Then the graph opens downward. So if A is negative, the graph will open downward. It's a frowny face because its attitude is pretty negative, right? Just like us. And its vertex, in this case, will be a maximum. And that's because the vertex is the highest point. All right, let's talk about, now this book calls it the standard form, but it's not really the standard form. Everyone else calls it the vertex form. So we're going to relabel this. That's how you learned it last year, the vertex form, okay? So just go ahead and write right over it. And we know the vertex form is f of x equals A. Now use your colors if you can, because when we're talking about forms, it's important that our brains know what means what. So we've got the value of A times x minus h squared plus k. And then we also know about this is that A cannot equal 0. So remember A, if it's positive, it tells us it's going upward and that it has a minimum. If A is negative, it's going downward and it tells us it has a maximum. And then the vertex is the point of h comma k. Okay, so the quadratic function in vertex form looks like this. The axis of symmetry, or the axis of the parabola, we call that the axis of symmetry, that's how we learned it last year, is x equals h. So think about it this way. Remember, if we have the vertex here, and we said that the vertex is h comma k, that axis of symmetry is going straight through that value. Well, that value of x is the same value of h. So we know the vertex and the axis of symmetry have the same value of x. And that we know that the vertex is, remember, h comma k. So we're kind of writing the same thing a couple different times so we know our brains have it. To write the quadratic function in vertex form, you can also use completing the square. We went over this last year. We will go over this together when I come back in class, okay? Also, you need to know that the x coordinate of the vertex is x equals negative b over 2a. Okay, so keep that in mind. To find the x-intercepts of the graph of our standard form of a quadratic, we can solve ax squared plus bx plus c and set it equal to 0. And remember, you would use the quadratic formula. You may have learned the song for that quadratic formula, or if you know it can factor, you can also use factoring and solve it by setting it equal to 0, okay? So let's go ahead and do this example right here. So it says sketch the graph of, and instead of using this graph, I'd like to use this one instead. So we'll say f of x equals x minus 2 squared plus 3. So let's compare this. We're going to identify the vertex, the axis of symmetry, and we're also going to find the x-intercepts. So a couple of things we need to know is that this is in vertex form. And remember, vertex form looks like y equals a times x minus h squared plus k. So looking at this, let's find the vertex. We know that the vertex is h comma k given the form. So let's find h. I look here and I know it says x minus. Here's x minus. So where is h? We know h is here, so this value, which is a positive 2, is our h. So that's going to go right here, positive 2. Another way to think of this is if there is a negative in front of your form, your brain is going to see the opposite. So just like we saw x minus 2, we know that that value there is going to be positive 2. And then we know k comes after the plus sign, so that's just 3, and that's going to go here. That's our k value, is 3. Remember, we also know the axis of symmetry has the same value of x as the vertex. So if we know x equals h, then we know x equals the same value that we found before, which was 2. These match. So let's go ahead and graph that on our graph over here. So we're going to go over 2. So here's 1, 2, and here's 1, 2, 3. There's our point. That's our vertex. We also know a parabola has that axis of symmetry through the vertex at x equals 2. Now to find the rest of our graph, we're going to find the x-intercepts. Remember, in order to find the x-intercepts, we're going to solve it and set it equal to 0. So in order to find our x-intercepts, we're going to set our function right here. Here's our function. We're going to set that equal to 0. So here we go. We get 0 equals x minus 2 squared plus 3. So let's solve that. I know I'm writing kind of little in here, but check this out. If I subtract 3 over, I'm going to end up with x minus 2 squared equals a negative. Can anything squared equal a negative? If you try to work that out, it doesn't work. There's no answer. So there are no x-intercepts, and here's why. Because if we go back and we look, here in our graph, we saw that the a value, there was nothing there, but so there's this invisible 1. It's a positive 1. So if a is a positive 1, then we know it's smiling. If I know it's smiling from my vertex, look, it's going to go up. So it's not going to cross the x-axis, which is why there are no x-intercepts. So it works graphically and algebraically. All right, let's talk about finding maximum and minimum values. The thing you need to know about maximum and minimum values is it's super easy. When you think of the word maximum or minimum, just think find the vertex. Okay? Now, depending on where your vertex is, if your A is positive and your graph looks like it's going upwards, this vertex is going to be, like we said, that's going to be your minimum. So when A is positive, it has a minimum. If A is negative and your graph looks like a frowny face, this vertex is going to be a maximum. So when A is negative, there's going to be a maximum. So we have to look to see which type of parabola we're going to be graphing. So if A is greater than 0, aka it's positive, it has a minimum, and it occurs at x equals negative b over 2a. Remember, that looks a lot like our vertex, because it is. And then secondly, if a is less than 0, aka a negative, it has a maximum, and that also occurs at that same negative b over 2a, which is also known as the vertex as well. To find the maximum or minimum value, just find the vertex, okay? So we would say it's either going to be a maximum of whatever value of y we find at x equals that negative b over 2a value. Or you would say it's a minimum value of whatever the value of y was at x equals the value of negative b over 2a. And that's how we're going to say our answer when we're finding the maximum or minimum value. We're looking for that verbiage, okay? So let's go ahead and do an example. Let's find the minimum value. So if they're finding a minimum, that's automatically telling me the graph is going to look like this, right? And let's see if it does. We know this is going to be a x squared minus b x or plus bx plus c. So I know my a value is 3. Because a is positive, we do know it's a happy face or it's positive. So this is a minimum. And we want to know where that is. So let's list our A, B, and C. A is 3, B is negative 11, C is 16. I'm going to plug this in. We know to find the minimum, we're going to find the x value of the vertex, which is negative b over 2a. So let's plug this in. Negative b is negative 11 over 2 times a is 3. So here I end up with positive 11 over 6 is the x value of my vertex here. Okay, so if I know that's my x value, how do I find the y value? Well, remember, we do have this statement over here, f of x is here. So if I've got f of x equals 3x squared minus 11x plus 16, that can just be rewritten. Instead of f of x, we can say that that's just y. So if I know x is 11 over 6, I'm going to plug that in to the value of x. So I can find what the y value is when x is 11 over 6. So let's plug that in. 11 over 6 and 11 over 6. If I plug this in and work it all the way down, I won't make you do it because it's a lot of fractions. We can do that later. But it's going to end up being 71 over 12. So if I know the y value is 71 over 12, when x is 11 over 6, we say the minimum is 71 over 12 when x equals 11 over 6. And that's how we would say that answer. All right, guys, that's it for today.